All right, so Meta just announced Llama 3.1, and probably the biggest part of this announcement is they now have released an open source model with 405 billion parameters, which is just crazy. That said, they also updated the 70 and 8 billion parameter models. So what I want to do is I want to grab a copy of the 8 billion parameter model. I'm going to pull it down, show you how to get that set up and running, and then how to tinker around with it, and a few things that I stumbled on when I started playing with this. And then I also, at the end, want to talk about this Llama stack that they're proposing. I think this is really interesting. So for now, over at the command line here, I would recommend using Ollama to pull a copy of this model. All you have to do is an Ollama serve, and then do an Ollama pull, specify the model that you want, like Llama 3.1. And I recommend passing the parameter count as well, just so that you know which one you pulled. So now when I pulled this down, and I do an Ollama list here, I have a few of these already just to save some time. You can see at the top of the list is the model I just pulled here. It's also the same as some of the other tags I've pulled. So if I want to specifically know how it was quantized, I could pull that label. And then I also have for Llama 3.1, I grabbed the 70 billion parameter model. That's not unreasonable to run on a Mac here. You're going to need about 40 gigs of RAM for that. And if for some reason you have like 300 gigs of RAM, you could definitely try out that 405 billion parameter model, which would be absolutely awesome. All right, and so in addition to Llama 3.1, I also have Llama 3, so I'll be able to compare that. So once you've pulled that down, you could, of course, do an Ollama run here, 3.18b. And of course, you could say, ask it a question here, get back your response. That's one way to go. I, however, have set up a little Python script. I was using this to test because one of the primary new features of the 3.1 series of models is the context window. Instead of the previous 8K tokens, it's now expanded to 128 tokens, which is absolutely incredible as well, because 128,000 tokens, by my math, would be at least a single book, whereas 8,000, I believe, might be just a couple of chapters of a book. So definitely a big difference in terms of feeding in information and getting information back. And so what I wanted to set up, and I didn't get all the way along with what I wanted to try out here, I ran into a little bit of trouble with the new 3.1 8B model. But I want to show you how to test this and show you the boundaries of that context window and approximately what that would entail. So I want to start out by just using a file right now that I created that has 4,500 tokens in it. And then I'm going to use that with Llama 3 first. And of course, I need to expand the context by default with Ollama. It's 2,000 tokens. So I've got the script here that's just going to ask a question here. It's going to list the top level sections in a document, that 1 to 4 dot markdown. Let me show you what that looks like here. If I cat out that 1 to 4, a ton of information in here that I generated, basically a long article. What I did though, if I grep through here for pound, I get the sections here. So you can see there are 4 sections. So my goal with this prompt here is to get it spit back that list of sections. So I'm saying that they start with pound. Please do not elaborate as well. And then I'm feeding in the markdown file at the end here. That gets sent off to the API generate here, gets a response back, and then it streams that response and prints it to the command line as it gets each token or each set of tokens. So first up, over at the command line here, if I run that script, you can see at the top here, it spits out that I'm using a context size of 8,000. It's the 1 to 4 markdown, and this is using Llama 3. So this is Llama 3 colon 8B. I should have been more specific, but. And there you go. You can see I get back a list that looks a lot like what I had when I looked inside the file itself. Those match almost verbatim. And of course, if I run this again, just to try it out and see what the response looks like now, once again, I get a list here that matches exactly what was inside the file. And let me do that one more time, just to show you the predictability of that. All right, so that is the first time. Over on the right here, we're going to run this a second time. But before we do that, I need to come over to my script here. And up at the top, I'm going to switch models here. Oops. So now I'll be using Llama 3.1, the 8 billion parameter model. Make sure to save that. And then back over at the command line on the right here, I'll run that again, this time with 3.1. And in my testing, this was actually kind of problematic at times. Sometimes this would work and sometimes it wouldn't. So we'll see what happens here. It's loading that model right now, and I should get a response. And you can see already, this is not exactly what I was hoping for. So one thing I've noticed with the 3.1 model, and I don't know if it's something specific to how Ollama quantized it, or if it's in the actual base model that was released itself, I just haven't been able to get predictable results. And sometimes I'm not even getting reasonable results out of it. Like there's no section 5. Sometimes I got it to actually give a reasonable list, but then it would usually go off on a tangent at the end here. So let's just try this one more time here. And yeah, so I don't know what it's doing. It keeps insisting there's some sort of a section 5. Probably because I have sections 1 to 4 in the document, and so it's now trying to write a section 5 at the end. Never mind that I prompted it to tell me what the top level sections are. And so just to prove this actually seems like an issue here, let me come back to my script. I'll switch over to a different file here, which has sections 5 to 9 in it. And then up above here, I'm going to switch back to Llama 3. So this is Llama 3 with 5 to 9. And if I were to bat out the contents of 5 to 9 and grep for pound, oops, and grep for pound, there you go. You can see the sections. And so now if I run my Python script again here, you can see this is Llama 3 now, and it's file 5 to 9. I had pretty good luck with this in my preliminary testing that it would actually summarize these smaller files just fine, the old Llama 3 model. And there you go. You can see it's giving me sections 5, 6, 7, 8, and 9. Exactly what I was looking for. If I do it again here, let's just see if it repeats. Again, 5, 6, 7, 8, 9. One more time here. Again, 5, 6, 7, 8, 9, and it looks pretty reasonable. All right, so that was pretty predictable versus what's actually inside the file. But let's try this now. Back over in my script, comment out Llama 3, bring back Llama 3.1, same 5 to 9, so save that. Over the command line, run my script on the right here, you can see this is 3.1 here, and it's 5 to 9. Let's just see if this works or not. Again, sometimes I had luck with it, sometimes I didn't when it comes to the 3.1 model. Okay, in this case, it's actually giving me section 5, which is correct, but then it's elaborating even though I asked it not to elaborate. I believe I asked it not to elaborate. Let's go check that real quick here. Yeah, I said do not elaborate. And then at this point, I think it's just gone completely off on a tangent, like somehow writing a new section 5 or something. I'm not certain. I wonder if it'll ever even get to section 6 here. No, I'm not going to wait forever for that. Let's just try it again and see what it does the second time. Now, perhaps I'm doing something wrong here. Perhaps I've messed something up in my script. If you see something that's off, let me know. But you can see right here, actually, it is finding some of the sections for me. AI in finance and business was one of the sections. AI in healthcare just doesn't seem to be following the prompt that I'm asking for. And yes, this is a very crude prompt. In this case, I'm just basically passing a question to it. That could be part of the issue, perhaps, with the new model. I need to use some sort of a template, some sort of messaging format to have the system message and the user message and the assistant responses. Maybe that would turn out to work better. I don't know. I haven't checked that out yet. It's just something that I noticed when it comes to using it in a very crude way, that Llama 3 seems to be superior in terms of predictability and getting a response versus Llama 3.1. And of course, if I try to use Llama 3, though, for something over 8,000 tokens, then of course that's going to fall apart. And if you want to see that, I can actually show you that. So Llama 3 was actually predictable, of course. However, if I come down here and try to load a file, instead of 5 to 9, if I try to use all, has over 9,000 tokens. Now when I do that, it's going to be truncated, and so we're going to have a problem here naturally. On the right, I'll run that this time. Did I get the right model this time? Oh, you bring back Llama 3 here. So Llama 3, 8,000 tokens, and the all file. Run that on the right here. And of course, the response here is going to be bogus because part of the prompt is truncated. Yeah, so you can see it's gone off the rails here. It's not even giving me what I asked for. So that's one case. If I were to come over here with Llama 3 and look at 1 to 7, this one fits inside the 8K token window. And I just want to show you in terms of predictability how this works out. So Llama 3 with 1 to 7, run that. And there you go. You can see it's actually giving me the sections. Does it get them all right? Let's see here. Section 6, section 7. Indeed, it does. Here's the actual original sections for 5 to 7. So computer vision, robotics, and AI. Yeah, you can see this is actually predictably working when I'm within the context window of 8,000 tokens. That's Llama 3. And of course, if I were to run this through Llama 3.1, I think once again, you're going to see it's just unpredictable. Maybe we'll try it real quick here. 1 to 7 with Llama 3.1. Again, this is within the 8,000 token limit. Oh, actually, maybe this one will work. I guess I don't know how this is going to play out. There was a few times when I got some good responses, but it was so far and few in between that I don't know what we're going to get here. Okay, actually, in this case, you can see it's elaborated when I didn't ask for that, but in this case, it's actually predictably giving me some responses that match. So section 6 is robotics and AI. That matches up. We got computer vision here. I don't remember 1 through 4 to see what it's got up here. I know that 1 was an introduction of some sort. So in this case, it has partially fulfilled the response here. However, it's elaborated when I asked for it not to do that. So that's a quick take on using Llama 3.1 versus Llama 3. Super easy to do with Llama. Pull that down to your machine. And if you are curious, come out to the Llama site, pull up the Llama 3.1 model here. They just published this recently. And in fact, it looks like there might be an update for this Llama 3.1 model. Tempted to see if maybe something got updated. Let's do this. Let's pull that again here. I'll just kill off the serve up above. I don't know if pulling a new model will trigger it to be reloaded. I'm going to pull and update the 8 billion parameter model, see if that actually works. Okay, that doesn't look like it was actually updated. Yeah, and if I look out here on the site, you can see actually the 8 billion parameter model that was 4 hours ago. So this must be a different size of model or quantization of model. I bet you it has something to do with the 405 billion parameter model. That one just showed up about 1 or 2 hours after the others. So it's possible they've pushed out different variants of that or different variants of the 8 and 70. All right, so I think that's good enough for now. The last thing I wanted to talk about was this tech stack. By the way, there's a blog post from Meta. There's also this primary llama-meta.com site that you can access. And I believe at some point you're going to be able to use this out on meta.ai. Is this possible to use yet? Okay, preview it. So I could try it here. So I could use it out here if I don't want to have to run it locally. I'll try the 405 billion parameter model. And then that's set now. Let's quick do this here. Let me come over to the command line here. And let me dump out the contents of that all file. Copy that to my clipboard. Let's see if it can actually summarize this. And actually, I should first grab the exact same prompt I was using over here and just see how it does. All right, come over to here, paste this in, and then come back to the command line, copy that again, paste this in. Let's just see how this does. Oh, that's interesting. It looks like it cut off part of what I pasted. Wonder if they have some sort of a limit to the context out here. It's got sections 1 through and then part of section 4 right at the bottom there. So they must have truncated what I pasted. But you can see this actually gets it right in terms of the 4 sections I wanted it to extract. So something must be up in terms of that 8 billion parameter model. If I can figure anything out, I'll let you know. Maybe I'll do another video if that looks interesting. But this does look promising here that you can use the giant model and get some meaningful responses, though I'd hope you could do this with the smaller ones as well. And then, yes, the last thing I wanted to address was this RFC for a tech stack. We normally would have just mentioned this and ignored it, but I thought this was interesting. So let me walk you through the steps here. So from my understanding of this system, we're talking about an architecture that we could standardize on, a tech stack called the Llama stack, where we first start out by prompting. That prompt goes to an executor then. The executor, of course, then passes off a prompt to the LLM, but before it does that, it can actually retrieve from memory. So it can retrieve any relevant memory details first, add those to the prompt, send the augmented prompt off to the LLM. A response will come back to the executor, not to the user yet, and it'll have the possibility that there are tool calls or requests inside of it. So the LLM could say, I need to run a tool to finish my response. So please go run that tool. That tool then is then run over here on the right. So you can see some examples of executing code, generating an image, and other various things like search or mathematical reasoning. The response comes back then, and then that tool response is passed back to the LLM. It then generates basically a final response, and then that final response is then sent back to the user. And then there's also a flow in here where the user can insert into the memory bank. And so this is something I'd encourage you to look at. You can even provide feedback. I believe this is an RFC. Yes, it's an RFC here, so people are requesting comments on this. And then for now, that's it. Tell me in the comments, what do you think about Llama 3.1? Am I doing something wrong? And do you have anything else you'd like to learn about Llama 3.1? Let me know down below.